Today, we're focused on P205B, Reductant Tank Temperature Sensor Performance. In plain language, the control side may not be happy with the reductant temperature signal. On a 2020 to 2025 Silverado 2500 with the 6.6 diesel, this may show up with a Service Emission System or Service Exhaust Fluid System message, and reductant pump, heater, or injector operation may be limited. Broadly, possible fault areas include the temperature sensor signal, the low reference, wiring, terminals, connectors, or the reductant control module. Start with the basic system checks. Make sure no other faults are leading the diagnosis somewhere else, and follow a structured diagnostic approach before getting into circuit testing. The reductant temperature sensor is a negative temperature coefficient thermistor. So as temperature increases, sensor resistance decreases, and the signal voltage changes. The control module input circuit has an internal resistance connected to 5 volts, and the reductant control module handles reductant heating and dosing. The typical scan data gives you some direction before you start taking the circuit apart. A signal short to ground is shown as signal 80 degrees Celsius, 176 degrees Fahrenheit. A signal open is shown as signal minus 40 degrees Celsius, minus 40 Fahrenheit. A signal short to voltage is also shown as signal minus 40 degrees Celsius, and a low reference open is shown as low reference 80 degrees Celsius, 176 degrees Fahrenheit. This code sets when the signal circuit is not within a calibrated range. The monitor has its own gates. Related enabling faults must not be present. The ignition off soak is greater than 8 hours. The ignition voltage is greater than 11 VT, and the monitor runs once per ignition cycle after those gates are met. Treat those as monitor gates, not as a confirmed failed part. With the ignition on and the vehicle in service mode, look at the scan tool reductant temperature parameter. It should be in the minus 39 to 79 degrees Celsius, minus 38 to 174 degrees Fahrenheit range. If it is outside that range, move into circuit testing. If it is in range, keep watching the parameter and make sure it does not spike or drop out. While watching that temperature value, wiggle the harness and connectors at the A38 reductant pump and sensor assembly, then at the K115 reductant control module. If the value spikes or drops out, repair the wiring, terminals, or connector issue as needed. If the value stays stable, reproduce the operating conditions for the code, or reproduce the captured conditions from the data, and confirm whether P205B resets. If it resets, continue into circuit testing. If it does not reset, the system checks OK at that time. For circuit testing, turn the ignition and all vehicle systems off, and disconnect the A38 reductant pump and sensor assembly connector. Give the vehicle time to power down. It may take up to 2 minutes before a ground or low reference continuity test is accurate. Test for less than 10 ohms between low reference circuit terminal 2 and ground. If it is 10 ohms or greater, disconnect the K115 reductant control module connector and test between low reference circuit terminal 2 at the component harness and terminal 18 at the control module harness. That circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, the diagnostic path supports replacing the K115 reductant control module. If the low reference to ground test was less than 10 ohms, turn the ignition on with the vehicle in service mode. With the A38 connector still disconnected, the scan tool reductant temperature should read colder than minus 39 degrees Celsius, minus 38 degrees Fahrenheit. If it reads minus 39 degrees Celsius, minus 38 degrees Fahrenheit, or warmer, turn the ignition off, disconnect the K115 reductant control module, and test for infinite resistance between signal circuit terminal 1 at the component harness and ground. If you measure less than infinite resistance, repair the short to ground on the signal circuit. If the circuit tests at infinite resistance, the diagnostic path supports replacing the K115 reductant control module. If the disconnected sensor reading is colder than minus 39 degrees Celsius, minus 38 degrees Fahrenheit, connect a 3A fuse jumper wire between signal circuit terminal 1 and low reference circuit terminal 2. Now the scan tool reductant temperature should read warmer than 79 degrees Celsius, 174 degrees Fahrenheit. If it does, the diagnostic path supports replacing the A38 reductant pump and sensor assembly. If the reading is 79 degrees Celsius, 174 degrees Fahrenheit or colder, turn the ignition off, remove the jumper, disconnect the K115 reductant control module, then turn the ignition back on in service mode. With the module disconnected and the ignition on, test for less than 1 volt between signal circuit terminal 1 at the component harness and ground. If it is 1 volt or greater, repair the short to voltage on the signal circuit. If it is less than 1 volt, turn the ignition off and test between signal circuit terminal 1 at the component harness and terminal 6 at the control module harness. That circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the signal circuit. If it is less than 2 ohms, the diagnostic path supports replacing the K115 reductant control module. After the repair is complete, keep verification separate from pinpoint testing. Verify the repair and confirm P205B stays gone. If the Service Emission System or Service Exhaust Fluid System message is displayed, perform the Reductant System Tamper Warning Service Bay test. That function clears the driver information message for the applicable system. The takeaway is simple. Prove the reductant temperature signal and low reference first. Use the scan tool response to split sensor side from module side faults, and do not call a module or sensor until the circuit checks lead you there. For more diagnostic training, visit stepdiagnostics.com.